Hey, hey. Welcome to Amber Skies. I'm Blades. And we're here. Oh yes, we're here. And look what we've got. Context, mini-game engine, and a triangle. Not the triangle. Oh my god, yes, the triangle. Oh. I can put a window in the middle of it. There you go, a triangle with a window in the middle of it. How fantastic. How fantastic. There you go, there's the code. I've put it back into the constructor. Just moved it up a bit. I have no idea what it's just done, but there was a question mark there and it altered something. Whatever. Okay. Gen the vertex arrays, or VAOs as I used to call them. Bind the vertex array object. Generate some vertices, or positions in this case. Create a vertex buffer. Bind the buffer, add the data, and define what the data means to OpenGL. And that's all there was to it. Down the bottom, in onUpdate, give us a clear colour. Clear. Well, we're only doing the top bit because the bottom bit doesn't matter. Does it matter if I can actually turn that on or not? Does it really matter? It did, it added a blooming space. Let's find out. There you go, absolutely not. Doesn't matter one bit. And the escape key works, yay! So we're clearing the colour buffer and the depth buffer, because we're going to be doing 3D, obviously. Are you coming over here? Come on then. Hello, Poppy. And that's all you have to do to render it. Now, will this work on your machine? Probably not. It's just that it happens that the graphics driver that I'm using is a Radeon graphics driver, and it gives me a freebie bits. It gives me free shaders with default values, where 0 defaults to the position. If we were to do this in 2 dimensions, what would happen? There we go, that's what it'll look like in 2 dimensions. That's completely legal. It still defines a triangle, but in 2D. So what actually have we got here? We have -5 -5, that's here. We then have 0 5 -5, which is here. But what's happened? Well, look at the first 3 numbers. we've now got -5 -5 at 0.05, which means that the Z value is 0.05, and then we've got -5 0 +5, which is irrelevant. So we've got -5 0, which is that point there. And then we've got 0 0 0, which is that point there, because we didn't give the data. So my freebie graphics shader is in 3D. Bet you weren't expecting that. Interesting. Interesting. So, to get my triangle, I have to correctly define it in 3 dimensions. Okay, so I've got that far. That's the first test. And all of this shouldn't work, because it's not complete. So we need to complete it, or should we do context? I think we might do the context first. Now we'll complete it. We've already got a context going for us. So we're here. We are at this point. Basically, we just have to do exactly the same thing. Sort of. Nearly, but not quite. I'm going to call this Vertex Buffer. I'm going to split that off. This is the vertex array. We'll split that off. So what do we need to do next? It's the index buffer. No idea. And this is why I split them off, because basically we should get 1 page out of each. So it's exactly the same. But is it? No, it's not. It's nowhere near the same, really, when you think about it. Because we're going to have a GL uint. And we're going to call these indices. Doesn't look right. Spell check. I wish I had a spell checker on here. Dice. Indice as. So it's dice with a plural. Indices with a small I. And we're just going to make those equal to something, aren't we? If I can get my keyboard to work today, we'll do a lot better. We're going to have 3 indices. And they will equal whatever we have down here. Now, how's about 1, 2, 3? Yeah. 1, 2, 3. Yeah, I think I can do that. That's a good set of indices. So we now need a gluint index buffer. So now we've got one of those, we can generate a buffer. GL gen buffer. We'll have 1, and it will be the address of, because it alters it, index buffer. Pretty simple stuff so far. Doesn't look too bad, does it? Let's next bind the buffer. And it's not going to be a GL array buffer, is it? No. GL bind buffer something or other. Okay. This is going to be fun. What's it called? What's an index buffer called in OpenGL? Well, it's not an array buffer. It's an element buffer, isn't it? An element array buffer? Really? Index buffer. Well, it's going to accept it, but is that correct? Good question. No idea. Notes. Do we have any? Okay, loading my notes up, that helps. It's OpenGL I want. Vertex buffers, binding, index buffers. Yeah, that's right. GL element array buffer. That's what they're calling it. Alright. So I've bound it. What do we do next? Let's keep it in step with what I've already done. So we bind it. Now we tell OpenGL to, or should I say, we load. If you noticed, this is a local variable. This local variable gets destroyed at the end of this function here. So how the heck did it know, or where did that data go to? Well, it went to the graphics card. And this is how we get it to the graphics card. We are going to use GL buffer data. So we're going to send it to the graphics card. GL buffer data. Where's my coffee? Because these are always funny. It's exactly the same as it was before, except that we now need GL element array buffer. I believe we're just using the size of. Yeah, we are. Does that give back in bytes? Doesn't tell us. Ah, who cares? It works. Size of. In dices. That one. Comma. Now what do you want? The data. And some kind of enum. GL static draw. What does that mean? GL static draw. What does it actually mean? Let's see if that place still exists. gl.com. No, that's not it. Oh dear. Is the... that's developers, that's on NVIDIA. Download OpenGL 4.6 for Windows. You can't. Doesn't exist. OpenGL isn't a thing. It's in your drivers. It's not something you download. You download your drivers. It's there. Oh well. Yikes. Oh, it goes to Kronos. Oh well. I'm going to use 410. Oh, goody. If you're looking for legacy, by the way, in 410 you won't find it. List of figures, list of tables. Well, here's your OpenGL. It tells you how it operates. Fundamentals. Oh wow, they tell you how to use it. Cool. Shared objects. Do they tell you what the macros are? How to use errors? Wow. Triangle strips. Alright. Okay, it's got quite a bit in here. I should read this. Vertex arrays. Woo. What about the macros? Okay. I won't be reading that, by the way. I'll try and find a better website for us. Okay. GL static draw means that we are going to load it up once and probably not change it. And we're going to say that we're going to use it multiple times to draw triangles, maybe, if we decide to. That's actually what it means. Ifs, buts and maybes. It's a hint to OpenGL or your graphics card for where to store your data. Does it need access to it all the time, or does it need access to it once? I mean, the opposite to that is GL dynamic draw, which means we're going to be changing it. So it wants it to be in memory, which we can quickly access and change. It's just a hint to OpenGL on how we are going to use the data, not how OpenGL is going to use the data. Okay. It becomes evident later on that we'll be wanting to draw more than one triangle, put it that way, because the model will be made up of quite a few triangles. Well, really, if it's a 3D model, at least 12 triangles. No? You can do it in 3 times 2, 6. You can do it in 6 triangles to get a 3D model. But for us it'll be 12, probably. Right, so I went off subject, didn't I? I just asked what it was. Why is this different? Oh, because it's elements array. These are elements. Yeah, they're different, aren't they? It's not an array buffer, which is full of floats. It's full of elements. So, an array buffer. How many different types of array buffer can you have? You can have as many as you like. It's a buffer. But you can only have one element array buffer. Roughly. Unless you need it for another model. Well, for one model. For one model, you'd have one array buffer. But you could have element buffer. You could have multiple array buffers. You could have array buffer for positions. You could have an array buffer for colours. You could have an array buffer for normals. What is perpendicular to your face that you have drawn? Things like that. Or, because this is vertices, you can stuff all of that information all in here and just have one. Because what makes up a vertex is not a position. It is a position, its colour, its doofree, its other doofree, and its other doofree doofrees. So it's full of doofries. That's what a vertex is. It's not a position at all. If you tell me that that is a vertex, it's not. That's a position. There's a big difference. A massive difference. The amount of data in a position is 3 floats. The amount of data in a vertex is going to be a hell of a lot of floats. So don't misunderstand me if I say position, okay? Because I'll be talking about position. Alright, that off my chest. Right, we're given the buffer data. Let's give it an attrib pointer, shall we? How are we going to do that? Well, do we? Is it an attribute? No, it's not. There you go. VAO indices. So gen buffer, bind buffer, buffer data, vertices. But we have attrib pointers extra in here. And then we can go into colours. Well, on this one, I actually gave colours as a separate buffer, so they went onto 1 instead of 0. Normals, they had their own buffer, they went into buffer 2. You see, the buffers are numbered, starting at 0, funnily enough. We use 0 because it's the first buffer to use, I guess. And it has to match up in your shader. So that's all you need for your vertices. But now, have we changed our rendering? No, we haven't. I haven't attempted to change our rendering. What would happen if I went 3, 2, 3, 2, 1? Now what would happen? Nothing. Why? Because we're not using it. The command to use it is not GL draw arrays. Is it? Let's think about that. We want to GL draw elements. What do we need? We need a mode, which is GL triangles. Because remember, we want to draw what is represented by our element or our indices. So that's why it's called this, GL triangles. We are going to need a size I count. Well, 3. There you go, I counted them all. What type are they? Uints. GL unsigned. Unsigned int. And const void star indices. What does that mean? Does it want our indices? Shouldn't do. What exactly is that? Let's ask the interwebby. Oh, I've got Kronos. Ah, this is okay. Yeah, I can use Kronos for this. So, const void star indices specifies a pointer to the location where the indices are stored. Oh dear. Now we've got a problem, because we don't have those. So we need a const void star indices. So we need void star and we need indices. Okay. I'll go with that. I'll accept the challenge. No idea where I've got that open. GL uint, and it's in dices with an M in front. Yeah. Yeah. Yay. Got it right. I'll also put a space between those because I usually do. We've got to start it off as something, haven't we? And we'll start it up as 0. Lovely. Oh dear. Ah. Does it want the index buffer or does it want the index buffer? Or what? That was a bit confusing. Specifies a pointer to the location where the indices are stored. Unsigned int, yes. Specifies the number of elements to be rendered. Yeah, render elements. Notes. Errors. Version support. Well, I'm using the right one. Why does it want the indices here? Should it not be the buffer? Something doesn't sound right. You see, all it needs here is num indices. That's why don't feel it's right. La 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 la. And I don't feel that's working. Like that. Anyway. It's a pointer. So that would be a star, wouldn't it? I'm allowed that. That's wrong. Come on, what is it? That's going to be awkward. It's an error, take it away. I'm allowed to define it like that. Wow. That is actually just gluing star indices. That's the same as saying that. Interesting. Don't like it. I'll keep it like that. Makes more sense to me. Will it run? Oh, no, it won't run because I've got an error in the code. And the error is... That's what it's asking me for, is it? Is it? It's asking me for that. Does it work? Well, I've got the wrong indices in. Does it work? No idea. Let's find out. Oh no, that definitely looked like errors. But no, I've got nothing on screen now. And we seem to have crashed the program a little bit. it's running. But it doesn't seem to be doing exactly what we intended it to do. So what's crashing the program? Is it this line? Well, we've stopped crashing the program, but we still got an error. Non-standard extension used. This member will be ignored by a default constructor or copy move assignment operator. This is in header 28.9. Guess what that is? Better do it that way then. Okay. Oh, absolutely happy with that. Good. I got rid of the error. Can we put the right indices in? 1, 2, 3. We want a positive test before I get a negative. I think that might be a good idea. Ooh, look at that. We've changed our triangle again. So that's gone to 0, 0, 0. I know that's point. That's your minus blah-de-blah. And that's nearly, yeah, that looks like the top. But we couldn't go minus. So it went to 0. So it defaulted. What happens if I use the buffer? You. What happens if we use this instead? We'll put it below. So now I want index buffer. Doesn't have to be defined. This is the kind of thing that I find interesting, especially when operating with something like this, where it's a state machine and all it is switches that you flick on and off. So I'm going to put those two in there, and I'm going to pop this in here. What happens? We get an error. Blank. Oh dear. Oh dear. Interesting. I don't think that's the correct answer. I do think it wants our indices. And we're popping them in as unsigned ints. So, let's do this again. And we get the wrong shape. Hold on a minute. What happens if I take unsigned out? Is that just an error? Yeah, that's an error. Unsigned by, unsigned short, or unsigned int. Wonder why it's doing that with our triangle. Do we know? I should really be checking, shouldn't I, for replies in chat. I'm asking the questions, but I'm not looking at chat, am I? No replies in chat. Okay, fine. I find that interesting, though, that it does that. It loses a minus. It gives us a 0, 0 somewhere. Is it starting in the wrong place, do you think? If we overrun the buffer, then yeah, we're overrunning the buffer, aren't we? So maybe that is 0, 1, 2, because computers count from 0. Oh, there we go. We've cracked it. We can now do a triangle using indices. So what happens if we type in 2, 1, 0? Can you answer that before I hit the button? I can answer it before I hit the button. I bet we don't see a damn thing. I bet we don't see the triangle. You do. Eh? Did that mean it just ignored the order? No, it just means that it drew the triangle round the wrong way round. It went clockwise. Or did it? Two, 1, 0. 2, 1 is... No, that's still counterclockwise. So to go clockwise, we have to go 0, 2, 1. So let's try that. So you could, it doesn't matter, this actually helps you get it correct, because you'd have to get it out of sequence. So what did we say? It's 0, 2, 1. So we've been drawing this counterclockwise so far, and this is the first time, because these are out of order, it goes clockwise. We won't see anything. But we do. Very interesting. So it doesn't really seem to matter what I do with my indices at the moment, but trust me, it matters. Go counterclockwise. Otherwise, you have to enable clockwise. And to do that, you'd have to type in something like GL enable, and it would be GL CW, I think it is. Oh, we've got CCW. Like that. And I guess we've got CW as well. Like that. Clockwise and counterclockwise. Well, it automatically starts in counterclockwise, so I don't know why you'd want to enable that. Unless you enabled one model to be clockwise, because some artist had saved it out in the wrong direction. Or you bought a model off the internet and it just happened to be in clockwise, and you hadn't written your loader correctly to detect that, or to be able to alter that. But I find that interesting. Just out of personal interest more than anything else. So I'm going to go 0, 1 and 2. We've decided that now, I think. And everything should work. That's the one I expect to work. Good. Now, what about this shader that I talked about? We haven't got one of those. So we're obviously using the default, and some people probably aren't even getting a triangle, so they couldn't do that experiment. How do you write a shader? And what is a shader anyway? What am I talking about? A shader is a program that runs on your graphics card. Nothing to do with light. Well, not much. The first shader is to do with position, not light. Well, it can have some light stuff in there, I suppose. It's nothing to do with light. It's about where you place the object. It's called the Vertex Shader, which is why people think that position equals a vertex, because the Vertex Shader does, well, positioning. It can do a whole lot more, but it does positioning primarily. And the Fragment Shader on your GPU does the fragments, the colour of a pixel. People say, well, that's to do with lighting, because that's where your lighting calculations go, because that affects the colour of your pixel, or how light or dark that pixel is. But that's not what the Fragment Shader does. The Fragment Shader just decides what the colour of a pixel could be. And it's called a Fragment Shader because that coloured pixel that it throws out might not land on your screen. It might be behind another object. And if it's behind another object, the depth test will say, no, that pixel isn't going to go on the screen because it's behind something already. And so that pixel gets discarded, or that fragment gets discarded. And that's the difference between a fragment from the Fragment Shader and the pixel that comes up on your screen. So if you hear me talking about pixels, I'm probably talking about fragments. If I'm talking about the fragment shader. Because I'm lazy. My brain doesn't work that fast to work it out that it's actually a fragment. Sometimes I make the mistake myself, in other words. It's just that when you're reading and you're trying to educate yourself, you get told so much rubbish that you eventually start believing the rubbish. And until you start experimenting yourself to get rid of the rubbish, it's very, very difficult to understand the truth of what's really happening. So we have two shaders. Yum, yum. What are we going to make these shaders look like for easiness? For ease of use. Can I get rid of all of this rubbish off me notes? Notes, stop it. Oh, God. Why didn't I put my notes on better software? Right, shaders. It's a good question. Where would I put them? Examples, maybe. I don't really put shaders in here, but I have. Alright, but I have made them somewhere else. Well, that's fair enough. Let's see if we can get ourselves a basic shader together. Now, the language that you write a shader code in is called Glsl. And we can set a shader up quite easily. At the end of each line of shader code, you have to have a \n. It has to be structured in the correct way. So we can't just make a string, but we can. So that's what we're going to do. I'm going to do a standard string. And I'm going to call it a Vertex Shader. I'll call it Source Shader. Vertex Shader. I'll call it Vertex Shader. It doesn't matter what I call it. And that's going to equal R. And that puts me the line endings on that I want. Hope it accepts R. Oh, we have to have brackets in, do we? Is that correct? Yes. That looks good. Cool. That nice little piece of code is in standard string. and standard string will sort the rest out for me. So the first line of a shader, what is it? It's hash version. Remember when I was saying that we had a hash version? I'm going to use 330 core. That tells your graphics card which version of Glsl we're going to use. Version 330 is 3.3, OpenGL 3.3, version 3, subsection 3, or 3.3. So that's the language I'm going to use. And we need, there's no semicolon on that, because it's a note. So, we have a position, and we called it 0 layout. So we're going to tell our graphics card what the layout is. And the location that we know of equals 0. And what have we put in? Coming a vec3. And we're going to call that position. I'm going to call that position. And it's a bit like C. Actually, it's a lot like C. It's got a semicolon at the end. We don't have any more locations or anything else. We don't even have a colour, do we? No, we'll give one more. Void. Main. Oh my god. It is C. You're right, it is. Well, it's a derivative of C called GLSL. Look it up. It's a fun language. And I can't go up or down now. Okay, now I can. You don't have to put a space in there. That's just the way I do it. I like to try and confuse the graphics card. And what we're going to do is going to type in GL underscore position equals, unfortunately GL position is a variable given or stamped into our graphics card. That's a given variable. And it equals a vec4. So we have to convert it to a vec4. So we do by adding 1.0f on the end of it. We always add 1.0f on the end of it because that's an homogeneous yeah, it's one of them because we're having a vec4. That's 4-dimensional. What's the fourth dimension? Is it 0 or is it 1? We use 1. We use the first of the fourth dimension, because there's a lot of the fourth dimension to use, and it's better to make homogeneous. Homogeneous? That's it. That's the one. It's a homogeneous number. It's fictional, and we use 1 to decide, well, to fix ourselves within the fourth dimension to a specific point, and that point is 1.0 or 0.1. No, that point equals 1. So, oh, needs a semicolon. It is C. That's it. That's your shader. And that's the default shader we are given by our manufacturer, usually. It could be a bit more complicated than that, I guess. Standard string. We'll need to do the fragment one, won't we? Fragment shader. And it's R open. Just give ourselves a bit of space. Okay. Actually, I usually put that one back here. It's the end. Okay, what we're going to put in here? Well, the obvious first line, which is hash. Tell our graphics card what language we're going to use. We can use anything up to 4.6 or 460. It's up to you what you use. It's not up to me. I think we've got 4.60 as a dependency, haven't we? Well, I have on this machine, I think. Easiest way to find out is, well, we get told that in here. OpenGL version 4.6.14 God knows what. So we can use anything up to 460 on GLSL if we want to. That's perfectly up to you what you use. What shall I put in here? I'm going to put a layout in here. I'm not overly sure you really need to do this because who cares? Location equals 0. But I'm only going to put out. I'm not going to put in. And we're going to type out a vec4 out from our fragment shader for the fragment shader color. Because that's what it does. It's only ever going to give us a color. I bet you guess what can come up next if you really wanted it to. Probably something like that. Yeah? Makes sense? I'll click, it's easier. Okay. Now what can we put in here then? F color equals something. What color shall we make it? So that we know that it's worked, because we've seen a white triangle. And I can tell you now it's a vec4. What should we make it into? RGB. No red. I don't want red. Let's have some green. 20% green. And let's have some blue, 40% blue. And what we're going to put as a fourth number? Well, it's not your homogeneous number now, but we're still going to put 1.0 because it's your alpha. The alpha value governs how see-through things are. So 100% solid is what that says, 1.0, 100% solid. And we need a semicolon. So I'll have that colour, and it's a solid colour. If I put 0.0 in there, you won't see a thing. If I put 0.5 in there, it will be 50% see-through, and whatever's behind it should, but won't, because we haven't told the GPU this, blend. So you can see through it, it'll look see-through. But it won't, because we don't have any blend functions defined for our GPU, so it wouldn't know what to do with it, and would probably ignore the fact that we put 0.5 there and stick a 1.0 there for us. In other words, it would ignore that, as it would be set to 1.0 no matter what. So it's probably just going to ignore that anyway. So if you want to play around with the alpha and find out, you can. But these are strings, and we can't just pass a string to our graphics card. These need to be compiled. This is C. We have to compile these. Well, there's a compiler on your graphics card just for you to do this. It's provided again by your manufacturer, and that compiler is available to you as an OpenGL command. Very kind of them, or set of commands anyway. And this is where most things go to trash, because how do you write this compiler? And this is the hardest part. And it's understanding all of this, which is where a lot of people give up with OpenGL and decide that 3D graphics is just not for them. There's too much math. No, there isn't too much math at all. There is if you do it this way. But considering what I'm going to do to this afterwards, there'll never be any maths to do. Because OpenGL is one of those things that you code once and forget about. Which is why I can never remember what to do. To become advanced within OpenGL and to be able to do OpenGL well takes considerable effort, because you would have to, one, understand the state machine. At that point, everything just drops into place, because everything's just a switch at that point. Every single one of these commands is just a switch that you're flipping, or a set of switches in this case, that you flip. Or register some data against and switch it on and off. And that's how a state machine works. It's just a box of switches that have default values, luckily. And there are a lot more shaders than these two on your graphics card. And you can program them all, I believe. Currently, maybe. Don't take that as fact. Right, we've written our shaders. What do we do with them? We have to compile them. How do we compile them? God only knows. This is something I've probably written, so it'll be in some kind of back-end system. Oh, please don't tell me I did this into a main. I bet I have done. Oh God, I have. Okay. I'm going to break this down into functions or I'm going to get lost. Okay, rendering. What do we want? We will want a return value, I'm guessing. Well, we don't need a return value. I think we'll be better off writing something for this. And it's going to be under the renderer, isn't it? Yeah, I think we are better off writing something for this. Compiling a shader isn't that straightforward. So let's give us something that compiles shaders for us. It's not something I would like to be writing every single time I want to use this kind of thing. So we'll come out of Sandbox. And I'm going to go into Amber Source, Amber Sky Source. I'm going to come down to our renderer. And what we're going to do is add new item, header file, shader. .h. And we will have a CPP. Let's just keep this as simple as possible, shader. PCH I've got to add straight away, and hash include its shader. There we go. What was the last thing we did? Time. There we go. Today's date is the 31st. Ooh, nearly got it right. And yes, you can get today's starting code off GitHub if you wish. It is open to the public now. You know me, Twitch, and there is obviously YouTube, where all past episodes of this are being stored. In the Minigame Engine series. Alright, where should we start? God help us all. Do I have to have this like this? No, I don't. Alright. Common. No type defs. Okay. It's OpenGL though. I'm going to put a renderer ID in here for later, in case I want to do the renderer. You don't have to put this in, I don't think. Really? Public. Because it won't matter. Shader, obviously. Constructor. We'll take in a const, standard, string, by reference, because we don't know how big the string is. And we are going to call it the shader Whoa, what happened there? Vertex Source. That's a nice big name, isn't it? And we're going to have the next one as a const. We're not allowed to change it, in other words. Standard string, because we don't want to change it, and neither should you be changing it. Fragment source, and that's all we're going to need, I think. May as well have a shader plink What else shall we have in here? Common does a lot for me, by the way. If you want to have a look at what I've got in common, it is everything that I'm probably going to use, and a couple of like event system, OpenGL, and logging. So I've got those 3 in as well, just in case I need them. And we will probably need logging in this, I would think. So with shaders, just like buffers, we do bind and unbind them. So we better have those. Void bind. Nothing's going to change. And void unbind. And again, it's const because we're not changing any data. We are going to be changing the state of our graphics card, but nothing within the game engine. That's all we're going to need at this point, I hope. Right, let's start with that. Let's see how far I can get with this. I will be writing the bind and unbind first, probably, because they are the easiest. Okay. That'll do for now. We can expand this as we see fit in the future. Pretty simple stuff. As we don't need to expand it at this point in time, I'm not going to. This file can get very big. Okay, I'm happy with that. Do bind and unbind first, I think. Yeah. Let's go bottom to top. So, unbind. This will be GL use program and to unbind a program off from your graphics card, you just type in GL false. There you go. Told you that was going to be easy, didn't I? So how do we bind? Well, yeah, we're going to use that render ID, I think, somehow. So GL use program. So we need to know what the shader is, what the shader program is, and I'm going to use an ID, and I'm going to call it render ID. You can call it shader ID if you wish, but I got a feeling I'm going to be writing a renderer because I don't want to keep writing renderers every time I want to do a new project. Okay, is there anything we might need in our destructor? Well, we're going to be making programs on our graphics card, and when this shuts down, we should really delete those programs. So we are going to delete program. and it's a GL delete. And if we have a look, there's delete buffers, there's delete programs, there's everything here. We haven't talked about deleting buffers, have we? We should do, really. And again, I'm just going to use my renderer ID, which you can call anything you wish, because renderer ID might not make much sense to you, but it practically means all the sense that I need. So we're up to this part now. Yeah, that was it. That's all we need for that lot. Now comes the fun. Let's write a shader. And that is m_renderer ID. Just put it to 0 for now. To be precise. We can use GL faults, can't we? Yeah. Alright, so it's still trying to work out what I've just done. That's great. Right, so the first thing that we're going to do we need to? Will we be altering the strings? Hey, baby. Hey, you just fell off my leg a little bit there. Don't know. So, we need pointers to shaders on... Well, no. We'll need a handle. It'll be a GLUint. That's for certain. We can call it Vertex Shader. And that's going to equal GL create shader. There it is. And that will just be a GL underscore vertex shader. Like that. Yeah. So create shader. We're going to need a C string. Shaders, as you saw, are written in a C style. GLSL is very much like C, but it's been modified into something called GLSL. So it doesn't accept C++. It is definitely more C than it is C++. So what we're going to do is we will make a C style GL char, which is GLSL, and we're going to call this source, I guess, and that's going to equal, we will have to cast it, won't we, to a const GL char. What is a const GL char? It's a char. If you look up the definition, probably at this point in time. What kind of thing are we going to need here? Vertex Source. And that's going to be dot C underscore string semicolon. It's not going to be vertex source, is it? Ah. Yeah, we've called it shader vertex. Will this allow us to do it? We're allowed to, it doesn't alter. .c string doesn't alter our source, does it? But it does. I can't risk it. We've told the user of this class that we're not going to change shader vertex source, and then we just do that to it. No. So I will call it vertex source after all. And it will be just a standard string. And that equals shader vertex source. We'll need a standard string. And we'll call it fragment source. And we'll put that equal to shader fragment source. A bit like that. Now I can use vertex source without worrying about the initial data that we've brought in being altered, because that would be disastrous if that happened. So we've now got some source. We're now going to tell our shader, GL shader source, and that will be a bracket, won't it? Right, what does this need in? Glint shader. Vertex shader. Next is GL size I count. Just one shader, please. Oh, sorry, one source. GL char const. That's going to be our source, isn't it? But it wants a star. Isn't source already a star? No. It wants a GL char star const star string. So it wants the address of our pointer. So that's source. What does it want next? Const glint star length. Work it out yourself. Is there a way to get through to anywhere else here? No. Fantastic. Just have to do a different search for every single one. Specifies an array of string lengths. If length is null, each string is assumed to be null, terminated. If length is a value other than null, it points to an array containing a string length for each of the corresponding elements of string. Each element in the... oh god, I'll let you... we're putting null in. Points to an array containing a string length for each of the corresponding elements of string. Okay. Work it out yourself, in other words. So I've only got one. Okay. In other words, we'll have to supply the length later, more than likely. Right. Let's compile it. Compile shader. Vertex shader. Does that look good? Yeah, that looks good to me. That's our glue int, isn't it? Yeah. That'll be alright then. GL int is compiled equals 0. And now you can start seeing why this is not the easiest thing to do in the world. What happens basically at compilation time is that because OpenGL is a state machine and it's on your graphics card, it will deposit into registers, I think is the best way of putting it, the results of how the compilation went. And we want to look at those results. We want to check whether it compiled or not. And there's damn good reasons for that, because we're writing shaders that we don't know that work. We have no way of testing them until they are compiled. And if they don't compile, how will we know? If you forget a semicolon, how will you know? That's the whole point. Just like any compilation, you want to see errors. Because if you have errors at compile time, it's obvious that the shader source is useless to you, and you need to rewrite it. Or correct it. You may stray outside of the language Glsl by accident and go into C. Which, by the way, you can do quite a bit of C in there. Trust me. It will accept a lot of C, plus there are a lot of terms in there that are specific to Glsl as well. Like some of the variable names. Something to be aware of. And as you can tell, there was no IntelliSense when I was doing it, because that's not a GL. We were doing it in C++, not a GLSL editor. So without highlighting and IntelliSense, you don't get any feedback. So you're basically doing GLSL at the moment, off the cuff, in the middle of your C++ code. Congratulations, it's the worst way to do it. We've just broken probably all the rules of every company going, and I don't care. So we need to know. There is something called GL, a get. There's a few gets in GL. We want the shader ones. So we'll put in shader. What do we get? Info logs, IVs, precision format, source. Not too many then. We'll have the IV, I think. Which stands for something. Is that the correct one? Return a parameter from a shader object. So I'll need the shader name or p name. That's an enum. And params. Returns the requested object parameter. Shader, delete, compile. How's about compile status? Ooh, we can check for the compile status using this. Let's do that. That's what we want to know, isn't it? Did it compile or not? And the parameter it returns will either be true or false, I'm guessing. I don't think there is a GL bool. Didn't think so. Because GL bool would imply that it could make a decision. It can't. It's a state machine. Doesn't rely on Boolean. It relies on switches. Alright, so what do we need? Glint shader. Well, Vertex shader. That's one that we're doing. Wanted GL compile status, didn't we? Compute. Where's compile? Oh, there it is. Just had to put that on, did I? And glint star parameter. This is the is compiled. Of course, we've got all of these stars in here, so we'll need an address, a reference, or whatever you want to call it. The address of is compiled. And it will deposit the result in there. Which means we can now check the result. if is compiled is equal to GL false, it didn't compile for whatever reason. So here comes the fun. We'll have an integer, a GL integer, max length. And now we'll put that equal to 0 to start off with. I think that's probably a very good idea to do. Now we need to find how much information OpenGL is willing to give us about this failure. So we don't know the size of the information. So we're going to do this again. Okay, and it's going to be Vertex Shader as before, because that's what we're asking about. But it's not going to be compile status this time. This time we can ask it for info log length. That one. And we can shove in there the address of max length. Like that. And that will give us the length of the information it's willing to give us. Lovely. At this point, I'm going to cheat a little, I think. The reason it's done this way is because it was designed primarily probably to be used with C rather than C++. Because now you could create an array of characters for max length. In C++, we can do it slightly differently. We can use a vector instead of an array. GL chars. And we're going to call it info log. And it's going to have some brackets. And it's not going to let me get to that. And inside those brackets, we're going to type the word max length, just to tell it how big it is. So a maximum length vector makes it easier for us to handle the information. Put it that way. Because we're in C++. So GL get, yes, we're back to getting. And it's going to be shader. And this time we're going to go for info log. Hey, Nimish DL. Nimish is DLL. Hiya, mate. Nearly got your name right. We're just doing shaders. Don't you just love shaders? OpenGL. We're just trying to get ourselves the... Oh, thank you, Nimish. Just call me Blades then, in return. Thank you very much. And yeah, we've just started to compile our first shader, our Vertex shader. And we've decided we're checking for errors. because we need to. So we've got this shader on the roll, as it would be. Let me just finish this one bit off. So on an info log, we would need our vertex shader. What do we need next? Buffer size. That's max length, we know that. Oh, didn't like me doing that. There we go, max length. Now it wants the length, but this time as a reference. It wants to know the length because it needs to make sure that something's happening, obviously. So we'll pop that in for it. And it wants now the characters of the info log, which is... well, we haven't defined that. Yes, we have. We defined it as a vector. So that becomes very easy. It's and info log, and it wants position 0 within that log. So that makes sense. Let me just pop this up onto GitHub for you. Nimish. So, creating a shader compiler class C++. Right, to get hold of this code, if you want to follow along or ask questions, if you go to, it's not my, well, it's my old name, Avengers /Amber Skies. If you go down to that on GitHub and under research, not the master branch, you will see that I'm currently working on the shader compiler now, because that's what I just put in. So under Amber Skies, under source, Amber Skies, blah, 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 renderer. What is Amber Skies? At the moment, it's a project name where I'm creating a mini game engine to help me write my game. And you'll see that Shader CCP is here. And of course, that's as far as I am right now. So that's up to date as of this second with all the code. So you can have a look at that if you want to try and follow along. So there you go. It's there if you want to. And hopefully we've now got an info log. So we don't need our shader anymore. Now we've got the information. So GL delete shader, maybe. Yeah, that one might help. That one. Because that's no good to us. And that's our vertex shader, of course. Easy enough. And now we can start giving out errors. Now we do have a logging system already within our system, so I can use AmberLog. What do I want? Error. And we can open those brackets. I will place in something along the lines of our shader class is reporting the error. And we're just going to have error, colon, a vertex shader, isn't it? Yep. Vertex shader. It's probably compile. How's about did not compile? Because that's probably a better idea, isn't it? That's getting a bit long. And then we can probably output the info data. That might be a good idea. So amber error. If you want to know what all of these are, these errors, or what this macro is, it's in our logging system at the same place. I'll show you that in a second. May as well do it that way. What can we put in here? We can put shader, obviously, because this is where it's coming from. That tells me where to look for it. And I'm just going to say that it's a variable. And the variable we're going to use is info-log. And all we're going to do is get the data out of there. I'll do it. Yep. Right, for this amber error stuff, we will find that in our logging system. But it's not actually in the CPP file, it's in the header file. So this is the logging system, and we have a set of defines for amber, which is the game engine, and we have a set for any developer who wants to use the game engine. So if we have a look in, I don't know if we're actually using any at the moment outside. So this is my research. Yeah, so I've got examples here, dev trace. So you can use it externally as well, but you would put dev instead of amber. And it will tell me on the console whether it's coming from amber or dev. So I know where to look, where the error's coming from. Clever little system. All that code's on GitHub. You can use any of this code, or 99.9% of this code, independently from the game engine. So if you want any of this code, just take it. Do what you want with it. There is no license to stop you. So, we've got our error. What do we want to do next? We've printed our error out, so we may as well just return. There's no point in continuing within this class or this constructor. There's no point in continuing because there's an error. We do not kill the program because we have printed out an amber error. So we can continue. There's no error, so it is compiled. We're going to obviously now assume true. We've decided it's compiled. I wonder why it does that. I'm not inside of that bracket yet, it still won't go to that marker. Weird. Have I missed something? No. Which one am I on? Oh, that's because I am on that one. That if statement goes out. Okay, that comes back in. Yeah, we are on there. That's why. I get confused, you know, very easily. Let's do a uint. we're always doing GL uints because they're nice. And we're going to do, believe it or not, the Fragment Shader. Hold on a minute. Can you feel in the bowels of your soul that we're going to be doing something like, let's repeat the code? Well, yeah, sort of. GL create shader. Let's do that. Here it is. And we're going to create, believe it or not, a GL fragment shader. And it's a couple down. There it is. That'll do. I'll drag you back though. It's looking good. It's looking good. So, our source this time is going to equal const star, wasn't it? GL char star, that was it. GL char star pointer to the fragment source. We need to turn that into C, Y, because that's basically what our shaders are written in. To C underscore, oh, it's coming up this time, that's nice. Must be getting used to us. Does that mean IntelliSense has actually caught up already? Good God. GL shader source. You can guess what the next commands are already if you've seen the first part. So let's fill in this thing again for it. This time we're going to use our fragment shader. Or fragment source? No. Fragment shader. Have I spelt it wrong? Yes, I have. Yep, that's better. Fragment shader, we want one. We'll have to give it the address of the source. And of course, the length, we've decided it can work it out for itself. Yeah, okay, I'm happy with that. Shouldn't we put null? Who cares? I know I don't. So we're up to that stage, folks, where we're going to compile our shader. What was it? Yeah, GL compile shader, most likely. Compile shader. Yay! Nice and easy. Nothing too difficult. And it just wants to know the shader. And we want to compile our fragment shader. That's it. Lovely. We've attached a source to it, so it'll be able to do it now. Now, we're going to have to look to see if there's an error. Good old OpenGL. Get shader IV. Which is that one. That one. I'll just put some semicolon there, and we'll just write these in. So what does it want? It wants the fragment shader, obviously. Remember, that's just a handle for OpenGL to know what switches we've flipped on our fragment shader, or what data we've given to our fragment shader. So it's just that. That's all it is. It's just a handle. It'll be a number, probably 2 at this point, or 1. The Vertex shader will probably be 1, and this will probably be 2, because 0 will mean delete, won't it? Yeah. 0 means there isn't one. GL compile status. So we can have view, and is compiled. Can you reuse the variable, obviously? May as well. Don't need to make any new variables here. And of course, after we've done that, we need to know if is compiled equal to GL false. And if it is, we've got an error. And of course, we've just opened the brackets. And our past brackets are dead. Remember, everything that I've done in here gets deleted when it hits that bracket after returning. So at this point, I will copy and paste. So, fragment shader, info log, max length, fragment shader, max length. Doesn't this tell you that something, if I'm doing this, copy and paste? Shouldn't this be refactored? Well, yes, is the answer to that. Am I going to refactor it? No. Not right now. Okay. So we now have our shaders compiled. Now comes the real fun bit. I think I need a cup of coffee. Sorry to say. Because we're about to compile a program. After you've compiled 2 bits, you've got 2 objects. We need to link those together, don't we? With any libraries that OpenGL may wish to use in a linker. Luckily, that linker is provided to us, and anything that it needs to link against is also provided within that linker. And it will do that automatically for us. So it does quite a bit of the work, or some of the work, but not entirely everything. That linker will be found on your graphics card, of course. It's supplied by the manufacturer and is accessed through the driver using an OpenGL switch. Quite nice of them to give us all the software for it and the hardware. Because these are actually burnt onto chips, EEPROMs to be precise. The driver EEPROM. So, how do we create a program? Let's do that. As always, OpenGL loves its handles, which is like a pointer, but it's not, it's just a number. So you might think of it as a pointer. So let's have one. And let's call it program. because that's what it is. And GL will create one for us if we ask it nicely. So it's create program. Just like that. There you go. Easy. We now need to tell this program which things we have compiled, or what we have compiled, and basically they call it attaching, and I think that makes sense really in some kind of unintuitive way. And I think you can guess what you're going to put in here. So Detach Shader requires a program and a shader. So give it a program. Just made one of those. And a shader. We'll give it the Vertex Shader. Hold on a minute. Oh, that's not the only thing we compiled. Well, guess what? You can repeat that command for what you have. And this time we'll put in program as before, because that's what we're attaching it to. And this time we will have our fragment shader. There you go. So I'll give you the next bit and then I want you to think about what we're about to do. So the next part is we are going to link program, use a linker. So link program. GL link program. You can probably guess what it's going to ask for. That. Now what do we need to do? What is our next step? The fun of OpenGL, and I need a coffee. So I'll go make a cup of coffee. Be right back, give us at least 3 minutes. Oh, damn, if I can walk. I hope I can walk. We'll see. Hey, weather monkey. Right, let's continue. I think you can guess what we're going to do next by now. We've just linked a program. Do you get link errors when you link any other programs? Yep. I think we're going to have to go and start doing this thing again, aren't we? Let's have... Oh, a keyboard over here would help. A GL int. And we'll call it is linked. We might need that. Gives the game away a little, doesn't it? GL get program. That strange thing again, IV. Information vector. Or vector of information. IV stands for info logs vector or whatever. You might want to call it... I think you can call it anything you want because they call it IV. So, program is the first thing we want. GL enum pname. GL link. Status will do. That's what we're after. Makes sense, doesn't it? And now we're going to have to throw this thing in. Pardon. It gives back a void. It wants a GL int star params. My notes are wrong. It is just a star, so it's a reference, is linked. I'm glad I read these things. Should have read them the first time round when I did my notes, shouldn't I? Alright, that should do it. Well, unfortunately, I think you can imagine what's really going to be starting to come up here next, can't you? We're going to say if is linked equal to GL false. Uh-oh, you've spotted it, haven't you? Oh, GL false doesn't happen like that. It's got to be capitals, it's a macro. When was the last time we did an if statement? Yeah, I think we'll take this. This. I can't take the last bit. And that's not supposed to be vertex. Nearly made a copy and paste error there. Can't take all of it this time. Shame. That's program. Get the length. info log, max length, blah de blah, blah, blah de blah blah. Okay. So I've got my program info log. Did I do my deletions correct? Yeah. So let's do our deletions now. No, I didn't. I missed one. Remember, if we got to this stage, we have already compiled the Vertex Shader. So that's another copy and paste error that you might make. And that is just the Vertex Shader. I'm happy now. Can you tell what's coming up here now? Ah, well. Probably gave it away there. So we would GL delete program. And that would be our program. I believe. Then we would GL delete shader. Is it? Yep, shader. I always do them in reverse order. So that would be our fragment shader, because we've already got this far. Then I would GL delete shader. You've guessed it, Vertex Shader. All right. Then we can do the errors. At least I was a bit more careful about doing it this time. So it's program did not link. All right. Hello, Poppy. And then we return. We do not crash the program or attempt to stop the program from running. We don't know how important this shader is to the person who's trying to develop it. So we're not going to crash our program just yet. Alright, so we're doing quite well. At this point, I can say something like m_renderer ID equals program. That is assuming that render ID and program actually have the same thing, and I haven't checked. Program is a GLUINT. A renderer ID is a GLUINT. Oh, goody! I got it right for once. That's probably something that I would get wrong half the time. Okay. Here comes another fun part. Once we have the program, we no longer need the other bits. So what I usually do at this point is detach. You can delete, actually. And I don't know if we did. I don't think it matters. They get killed at the end. Yes, that's alright. GL Detach Shader. Before you can delete a program, you must detach the shaders. So it's going to ask from what, that's the program, and which. And we should start with the last one made. Always do in reverse order, if you can. You don't have to, but it just makes more sense to my mind if we do things in reverse. Detach Shader. Program. And Vertex Shader. And I think we're roughly about done. That should kill them, because neither the vertex nor the fragment shader are member variables of the class. We wrote a bit of code there. Yeah, just local variables. So they will be deleted. I'm not sure I like that idea like that. So I'm going to specify it. Detach and delete. It's memory on your graphics card that you're deleting. So if we don't do that, would we cause a memory leak? How the hell would we know? Because the memory leak would be on your graphics card. How do you detect a memory leak on your graphics card? Please let me know. Stick that into amberskies@virginmedia.com, because I have no idea. So, am I trying to avoid a memory leak? Yes, I am. Will that kill the shaders? Yeah. Will it kill the program? No. Your final program has nothing to do with your code. You can delete your code and still keep your program, can't you? It just means that if you want to remake it, you'd have to write the code again. And as we're not going to be remaking it, who cares? So you're better storing your code in your code. And that's exactly what we did. So we've got a class now that exists and is completely wrong. Is it? No, it isn't. That makes a shader. I hope. Okay, we popped it in here. It succeeded. And it's got a load of linker warnings. How do you get rid of those linker warnings, I wonder? It's the same linker warning every single time. It's linker 4006. Hold on a minute. And it's coming from I'm GUI build. I've got a librarian. I can treat them as errors. That'd be hilarious. Why is it giving these warnings? Interesting. So I can't really get rid of them, can I? That means there must be a macro I'm missing. It's being produced by a clash between I'm GUI and GLFW. Where I'm GUI is just repeating the code within GLFW, I believe. Yeah. And it's also repeating code inside of OpenGL 32 lib. So I need to, it's an I'm GUI definition. Define. Jesus, it's a hell of a lot of defines. Oh, we're supposed to be testing if this works or not. Forgot about that. Shall we see? Don't get distracted. Sandbox rendering. We've put some OpenGL together here. It looks very nice, and we've got some shaders. So let's have a shader. We can go into, I'll keep these two open, I might have to refer back to them. Oh, that's a good point. Amber Skies would need to have it, wouldn't it? Okay. I'll allow that. Otherwise we can't access it. So this is under renderer. And it's hash include. Amber Skies / renderer / shader. Complete. Right, we've got access to the shader now. That might help. So I shall put in here shader, no, amber, ::, shader. Aha, it's there. Isn't that ace? I love the way this works. M_shader. basic shader. Or default shader. Basic shader. Done. There we go. Do we need that to be a... it's... what... there. How big is that class? Don't know. Is the answer that people should come up with. So let's make one. Can make one here. Equals a new amber colon shader. We can't really say that, can we? Interesting. Because it's wrong. Nope. Don't want that. Don't want to have to deal with it. I'm going to make that a thingy. And that will be an std colon it'll be a shared pointer, won't it? That'll work. And now I can use it how I want to use it. Not like that. Alright, here's our shaders that we have written out. Remember to put the R in the bracket, otherwise it won't work. You have to have a \n at the end of every single line that you write. That'll do it for me. But now I can write that. And that's important, I think. It could be important. What can we do with this now? Swap, get, or reset. Oh, we'll reset it because we haven't used. Well, we're about to use it, aren't we, for the first time? So we'll use reset. And now we can put the word new in with safety. We'll have a new amber shader. And I don't have to put it up at the top. And we are going to use 2 items. I'll use that one. I'll use 2 of 2. So shader vertex, that's Vertex Shader. Does this need to be a constant or anything? Oh no, it doesn't matter on our side, does it? Vertex Shader, and you will want the other one as well, won't you? The Fragment Shader. And there's your semicolon there. And that's how I call it. And that should make us a shader. And how do we use it? Well, where we've got bind vertex array here, we can now bind here. We're not going to unbind because I can't be bothered. And it doesn't matter because we're only trying to do simple things. But after you've drawn the elements, you should first unbind your vertex array and then unbind your shader. Do it in reverse order. I thought I just lit that. Weird. And now I can have my coffee. Will it work? Will we get a triangle? Can anybody notice the difference? That's a blue triangle, not a red one. Why is it a blue triangle? Because I made it blue. Simple answer. Let's try a 5 there, a 2, 5 there, and remember these are percentages, so 50% red, 25% green, and blue will give that, what, it's supposed to be 12.5? 12. What colour is that? It's amber. Gold or orange, whatever you want to call it. So our shaders are working from that piece of programming. Let's find out how well they are working. Let's forget to put a semicolon at the end. Remember, it won't crash our program. You get your white triangle. Why? Because this happened here. Remember, that's the default that we get from the manufacturer, which is why I wanted to show people that I get a default. Most people just get a blank screen. Because we put that macro in, Amber Engine is saying that there is a shader error in the Fragment Shader. It did not compile. The fragment, this is the log from the graphics card. Fragment Shader failed to compile with the following errors. Error 013, error number 132, syntax error, plump parse error, error number blah 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 blah, 1 compilation errors, no code generated. Hold on a minute, it came to the end with an error number 132. 013? That's that some kind of line number? Well, it is. It's line 0, number 13. So how do you understand that error? It's telling you that you've probably missed one of those, but it isn't telling you that at all. It's telling you that that is a syntax error. What it's telling you is get you out of the way a second. That is a syntax error. Which it is. But at 013, hold on a minute, isn't that line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? That's nearly 13. Does it mean it's 13? Are there 13 lines here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, there's 11 lines of code. So that's obviously not right. But 13? Well, that's ignored. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hold on. Where's this coming from, this 13? Understanding these syntax errors is quite difficult. It is right on that. That is the actual syntax error, because that is a syntax error. That is wrong. What it means is the line before. So the error's here. Okay. Can't do it that way. Got to do it that way first. Alright, let's run that one. A different error. Syntax error is a semicolon. Well, it is the syntax error. That's quite right. The semicolon is the syntax error. Which one? The one on 11. Hold on a minute. 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. So because of the way we've written it, it's a 1 actually, because that's there as well. That is the start. We've left a blank line, to be quite honest with you. So that's the line number. And we've got that now. But that is line 1 there. That little flashing mark. It isn't a big line, it's just a small line, but it's there. I believe that that's a line there as well at the end, where the brackets are. The brackets constitute a line. It's a syntax error, so it's reporting it correctly. Now it works out what the line numbering system is. So it's definitely this line, and the syntax error is that there. But it's not an error, it's actually just before it is the error. And that's what you're going to often find with this kind of thing with OpenGL. The reporting of errors isn't really there. This one's an interesting one. Let's try that. And if anybody's getting a bit annoyed about my GUI being in the middle of the window, we'll stick it up there for now. What error do you think we got this time? Oh, we got something different this time. Layout qualifier does not apply to generic variable. Yeah. It needs a qualifier. It needs to know, is that colour coming in or out? It calls it a qualifier. You would probably have to look up what OpenGL shader error number 386 was to work that one out. Oh, sorry, that's out, isn't it? Whoops. It wouldn't know the difference. That would be actually a valid... Oh, yes, that's a good point. I should have said, is that an error? It is. Fragment Shader failed to comply. Error. Explicit attribute location in Fragment Shader is only supported for the out storage qualifier. So it knows there's something wrong straight away. You can't have a layout location going in on a Fragment Shader. Only on a Vertex Shader. If you take that layout location away, that is valid. But you can't have a layout location. L value required, assign F color, can't modify an input, cannot assign to in, 3 compilation errors, no code generated. So that is a better description. Well done, guys, you got that one nearly right. You can't do that. That's illegal. You can only put in for a Vertex Shader. You can only bring things in via the Vertex Shader. You are allowed to pass from the Vertex Shader to the Fragment Shader, and that's roughly about it. The only way you can bring in other variables from the outside to a Fragment Shader is by using a special variable type. So it is possible, but you'd have to use a completely different idea for that. There we go. That's shaders. Ah, hold on a minute. We can do colour now. Yeah, we can do colour. Does that work? No. I still haven't worked that out. That's I'm GUI. I'm still working on that. Hold on a minute. So we can't bring things in here. We can only send it out. Ooh, well, how's about layout, location, I've described this already, equals 1, in vec for color. That's allowed. How's about we say that V color, our Vertex Shader color, equals color. That's right. That's an error. We haven't defined what vColor is, and it's not like this variable here, which is given to us by the manufacturer or OpenGL. This is our own. I've just called it vColor to say that it's coming from the Vertex Shader. That's all I've said. So, oh good, I can put it here. I'm going to put in out vec for vColor, so it knows what it is. Put some semicolons in to be a nice person. Down here, we have to do the opposite. We have to put in vec for. And it has to be exactly the same or it won't match up. vColor. And here, we just change all of that to vColor. What does that mean? This could be interesting. What does it mean? Well, it means, for starters, we've now got an extra location. It also means that it's expecting us to give it the colour. So let's do that. Where shall I put the colour? I can place the colour in another set of these, but I don't want to. I'm going to put it in here, because I'm like that. What shall we have? 1.0f. Hold on a minute. Oh. This is why they're called vertices and not positions, by the way. Alright, so the bottom left corner is going to be red. We hope. Well, we're going to ask it to be anyway. And of course, alpha, always don't make it see-through. Better put commas on the end of these, I know. I'll make the second point green. Oh, I'm going to have to add some stuff here. It's still complaining at me, isn't it? And I carry on as if nothing's happening. And the last colour that we know in RGB is blue. Which is that one there. 1 and 1. That is correct. Ah! It's squiggled at the 9th position. Well, the 10th position. It's not big enough. So we don't have 3 things describing our vertices anymore. We have 7. 1, 2, 3, 4, 5, 6, 7. Yeah. There you go. That's legal. Our vertex buffer is created. Size of vertices is calculated as 21 times the size of a float. Our vertices is our data. We have a static draw. we have our first attribute pointer for 0, 0 here, and we've described those floats as 3s, and we have enabled it. But I'm not going to be enabling the colour, so we shouldn't get any. No, that's what you get. You get something very, very strange happening, because what is actually happening is, yes, your colour's being ignored, but the 3 of 3 isn't being ignored. So those are the first 3 for position. That's your next 3 for position. And that's your next 3 for position. The rest is ignored. Do you see the problem? So you must tell OpenGL, hold on a minute, we've added this extra data. This is no longer true, basically. And we've also got to enable Vertex Attrib Array 1, maybe? That might help. Let's see how we can do that. And see if I've got any notes on it. I haven't, have I? Alright. OpenGL notes are in buffers. Correct. Where are my locations? That's not helpful. Our element stays the same. It's our OpenGL that doesn't stay the same. Let's see what kind of command system I want to structure into this. Am I going to use a command structure? Not that heavy. An API. It's how you construct the layouts that's going to cause me the most problems here. Constructing a buffer layout. Oh, that's bloody helpful. I hate it when I've been helpful to myself. Offset stride, yeah. It's these offsets that are going to kill me. Which one? Index is your first number, size is your next number, GL enum type is your next number, Boolean for normalized, yeah. It's this 3 times the size of a float is your stride. So that needs an offset really, doesn't it? What's stride measured in? GL size I. Alright. Let's put one in and see if we can use it. So a GL size I, and we're going to call this offset. And that's going to start at 0. Now I need to look at the element. Where am I getting an element from? Okay. So the offset is 0 initially, and then the offset is offset plus that. So offset plus equals 3 times the size of a float. I'm doing it this way, otherwise I'm going to get confused. And trust me, I get confused easily. Alright. Isn't that what we started at? Yes, it is. So offset starts at that. Then we have to add the next one. I'm not overly liking that. Because that's your stride. If you take your offset and add the element side, you've got your stride. And that's what that's asking for. That's what my notes say. It is. That's what it's asking for. That's what it's asking for there. Oh, I don't like that. So the next offset will be offset plus equals and then it's going to be 4 times the size of a float, isn't it? This better work, or I'm going to be rather annoyed. According to what I am looking at here. Pop that there. And now we should be able to do it. So we should now be able to do a GL, a trip, vertex, a trip pointer. But it's not going to be null. What's that last value called? The last is a pointer. So pointer equals offset. What's it in? It's a void star, isn't it? Const void star pointer. Okay. Doesn't really matter what put in then, does it? I'll use a uint because they're smaller. Gluint pointer. Is that a valid name? No, seems we're allowed to use it. Equals offset. I knew there was a reason for doing it this way. Haha. So it's GL. Vertex, a trip pointer. Vertex. I can never see this one. There's array. Oh, that's why. Okay. A trip pointer. Right, we've got down to 1 there. Good. And the first thing it wants to know is 1. So we're on to 1 now. This is layout location 1 we are describing, or the colour. So the index is 1. The size is 4. They are GL floats. So it's 4 GL floats. Normalized GL floats. Normalized means brought down to a range of 1, and with colours this matters. I've done them in decimal, not 0255 as you may understand RGB can also be used as. You can have RGB in the range of 0 to 255 as well. The reason I use percentages is because you can fine-tune it a lot more down to about 6 decimal places. It gives you a lot more variation in the colours you can use. Otherwise you can only use 0 to 255. And then you'd have to put that to GL true if you did it that way. So you can if you want. You can try it out. We might try it out. Now we need the stride, which is offset. And next we need that const void star. Const void star. And that's to go into the address of pointer. It's not complaining. So all I'm doing is I'm casting the address of a GLU int to a void star. In other words, it wants to accept that data for whatever it actually says in numbers. It doesn't want to accept it in any other way. So you could use characters there. That's C, by the way, for you, not C++. We better enable it as well. GL enable vertex trip Is that right? Array. Yep, that's right. Good. And we just want to, number 1, please. Bob. Semicolon. That's it, done. So we've added layout 1. Will that work? Why did I place the pointer to the offset? Why did I replace that? Because you have to point to there. And that is 3 times the size of a float, which is 12 bytes in. So we already know that, we've already calculated it here. So that pointer will point to the 12th bit. See, it's going to take 3, then it's going to take 4. But where does it take the 4 from? 12 bytes in. What's the stride? I don't like my stride. I like the pointer but not the stride. I don't think that null pointer there is going to work. Shouldn't the stride be the same? The stride is the size of the whole thing. Is it not? So that would be the pointer. I think it is. I think I've got it wrong. And the computer agrees with me. Have we crashed? Looks like it. Wish it wouldn't put it there. So that's not quite right. I'm thinking I was thinking correctly. Yeah. Pointer equals offset plus four times the size of a float. If I get this bit right, it makes it easier for me later on when I try and work out these things. So the initial offset is now correct, but the pointer isn't. And that's a const. That's the address, isn't it? Const avoid star, and it'll be and pointer. Is that correct? Stride should remain the same. Pointer, redefinition. You're right. Whoops. Still not right. How do we get the offset and the pointer? That's definitely the stride. But I think the offsets are wrong. I think my pointer's right now. That makes more sense to me as the stride. So, shouldn't really call it that, should we? I'm happy with that part. What I'm not happy with is that it should start at 0 as an offset. Yeah. That was my initial intent. If my initial thing is to put something to 0, then it's usually correct. Then you need to be an offset of 3 floats in to get to the first colour, which makes more sense. And the stride stays the same because it's always the same stride. It's always from there to there per vertex, from there to there, to there to there. That now starts making sense. Which means, when it makes sense, it's usually correct. And it's not. But now we're not crashing the program. Now that's interesting. Okay, that's very interesting. It's not right, but it's righter. So what we do next is we take our attrib pointer, we copy it, and we pop over to our lovely, lovely, lovely web and find out exactly what that is in OpenGL. Okay, we want the top one. Okay, so the index specifies the index of the generic vertex attribute to be modified. The generic vertex attribute means the number that's in your shader for layout location. The size I've put 3 there and 4 there. Specifies a number of components per generic vertex attribute. It must be 1, 2, 3 or 4. Well, I think we're within boundaries there. The symbolic constant GLBGRA is accepted by GL vertex attrib pointer. The initial value is 4. So we've got that right. But we've used RGB. Don't tell anybody that we've used RGBA. So, type specifies each component in the array, floats in this case. Normalized, we're not bothering with that because we haven't put 255, 0 to 255 in for our color. Stride specifies the byte offset between consecutive generic vertex attributes. If stride is 0, the generic vertex attributes are understood to be tightly packed in the array. The initial value is 0. Is this in bytes or is this in what? Byte offset. It's in bytes, so I've calculated stride correctly. I was right about that. Alright. So stride equals the whole goddamn thing. No. No, that is correct. Alright. Pointer specifies an offset of the first component of the first generic vertex attribute in the array in the data store of the buffer currently bound to the pointer specifies an offset of the first component. The first component is that. The offset is 0, so we place 0 in. Offset 0. The next offset is that, so it's 3 floats. Is it just 3? Is that where I've gone wrong? I've put it in bytes, haven't I? It didn't mention bytes. A pointer is in memory addresses. description, notes, errors, yeah, associated. That's the only help they give you. That's not a very good sentence to read. That's more confusing than the actual thing. It doesn't mention bytes and the initial value is 0. Okay. Stride 0. The offset I'm liking. Oh no, Strider was liking. We didn't put 0 in the first time, we put 3 times the size of a float. Okay. Interesting. Because that's how many bytes it takes up, isn't it? Okay. I've got to know this equation. I want to find this equation. So the first thing I'll do is try putting that in there. Okay, we haven't got anything yet. Oh no, we've got the black screen of death, haven't we? Okay. So that's totally out. Interesting. No, that'll be... the reason it's crashing is it's overflow, buffer overflow, isn't it? So it's not going to work with 4. That's black screen of death. Yes, good. I am understanding this properly. So that is the correct value. So that will be 0 and that. Now why would the stride be wrong? Because we've done the stride in bytes. Could the stride just equal 12? Okay, let's try that out. Right, now we've got something. Bam. What have I missed now? Here? Ah. Whoops. Okay, we're back in the realms of reality again. Right, only enable vertex 0. Cut down on your variables. That's your first thing you do. Now we know what works. Stride equals 0. A null pointer. Let's see if we can use a variable here first of all. And let's see if offset of 0 works. Nope. Nothing there. Let's try taking offset out and putting in the correct thing. No. So it's a variable. Turn stride into 0. You can't and a 0. You can do that though. That's a good old C trick. Null pointer. Oh, yes. We're up and running. It's the fact that we're using the word stride, is it? So what is the distance between each of the first items? The distance in stride is from there to there. So that is 12. No, 7 times that of a float. Okay. 7 times the size of a float. Do we believe that equation? Well, that's not as bad, but it's obviously not right. I wonder why that's not right. Let's try that one. That's, oh wow, we've seen that before. So maybe it is 3. That was an overflow last time. No, we're back to that one again. I'm damn sure it's 7. It's a pointer. Oh, stop guessing. So what is this pointer? What size is this pointer? If we make it 3, it gives the same as 0. That makes sense. So it is 7 times the size of a float. But that must be true for everything. Let's go for size of vertices. Okay. And we have 3 divided by 3. That should crash. No, it doesn't. But it is showing something which is a bit weird. Because that's 1, 0, 1. That's a colour. That vertex, sorry, that position there is a colour, or the end of a colour. And I can see that straight away because we've got 1, 1. That's minus 0.5 minus 0.5, 0. That's 1, 0. And that is, I can get the x and y coordinates out of it. So where do we get minus 5 at the beginning? No, that's not the beginning. 1, 2, 3, 4, 5, 6, 7, 0.5. Positive, minus 5. It's going from the 7th. So we need it to go from the 0th. It has to be 0. Otherwise it doesn't make any sense. Three times the size of a float. I'm thinking of this the wrong way around, aren't I? So the stride is wrong. Gotcha. That's your stride. That's allowed. And the pointer for this one should be 0. What happened to my other bit? Come here, you. Stop working. There you go. Done it. Understood it. At last. Didn't take much working out, did it? So we've got the stride. What we need to do now is work out what happens next. How do we get the colours? Because if you notice, it's black, which means we're not passing in any colours. Everything's at 0, so we're passing through zeros. If you don't pass your colours in, it will make them up for you. And 0's an easy number to plug in, so that's what it does. So now we know that, we can probably work out what this should be. And this should be, stride should be in here. We had that totally wrong. It's the same stride for both. And this will not be 0, it will be 3 times the size of a float. Or offset, which we can't use. Until I know how. Just a number will do. Take that out. And we'll enable it and see if we get any colours. How about that then? Getting a shader working the proper way. By investigation and understanding rather than following somebody's script. And there's your colours. We asked for, make sure that your colours match. Don't just take, the reason why I did 3 different colours like that is because they're easy to work out. Red for the bottom left, green for the bottom right, and blue for the top. Are we right? Are we correct? Does our shader work? We have proved it works, and we have proved how to place the data into our shader, doing it slightly mathematical. But what I want to know is, why doesn't offset work? Because it isn't offset that it's looking for, is it? That's an address. So let's try and understand that a little bit better, so we can try and use offset. Offset equals 3 times the size of a float. So really, it's a number. It'll accept it as a number. And it works. We have now found out how to use offset. Believe me, I've been trying not to show you the truth. This GL faults we can now test. What would happen, say, I wanted to put in red, green, blue, but not in these kind of numbers, in 0 to 255, which people are used to doing. I don't think I've got anything to show you with a 255 on it, have I? Do people know what I mean? Doing colours 0 to 255. Are people used to that kind of thing? Is that normal these days? It used to be in my day. Is it still the same? I've not thought about that. This is interesting because how would it normalise it? And what does normalization really mean? Specifies whether fixed point data values should be normalized or converted directly as fixed point values when they are accessed. Well, that's helpful. Well, yeah, this is what I was trying to say here. It indicates that the values stored as an integer format are to be mapped to the range -1 to 1 for signed values, or 0, 1 for unsigned values. When they are accessed and converted to floating point, otherwise values will be converted to floats directly without normalization. I can't show you because we can't mix them. They'll go in as GL floats. We'd have to have the colours separate in a separate buffer, which you can. Don't have to be in the same buffer. But that's what normalized means. It means it takes values in a range and puts them between 0 and 1 as a floating point, or a percentage, as I call it. 0 to 1, I always call in floating point a percentage because that's what it is supposed to represent. You times it by 100, then it actually looks like a percentage. Well, well, well. So that's how you would make your first triangle, is it? You got your shaders. We made a shader class. And we drew it. And I've been lazy. Alright, let's stop being lazy. Let's show you the proper way of doing it. So we're okay up to here. At this point, you should start unbinding your buffers because you've been binding them. Now, GL bind buffer overwrites. Or does it? Because it depends on the type of buffer. We've got an array buffer. Didn't we have one before this? Okay, we've got a vertex array. We have, this is what we've got bound. We've got an array buffer bound. And this last one is the index one, isn't it? What did we bind here? An element array buffer. So we've got 3 different things bound here. So we've got 3 switches saying, hey, look at these buffers. and we've slotted them in. Maybe we want something different. We'd have to bind something different. I'll show you ways around that some other time. So we should do it in reverse. So we should take that one first. How do you unbind a buffer? Well, it's pretty easy. I use GL false. You don't have to. You can use 0. By the way, if you're wondering what GL false makes, it expands to be 0. So you can put a 0 there if you wish. I prefer to put GL false because it's up to OpenGL what that means, not up to us. OpenGL can redo their specifications in 1 year's time, and everybody's programs will fail because they've all got 0 in there. Because they will say that GL bind buffer to unbind the buffer is not 0. We're going to make it 255 or -1 or hexadecimal FFF F F F F F F F F F. So let's have a look at that instruction and see how they are guiding us at the moment. This is interesting because I don't know. I like to look up things I don't know because I like to research things. So these are all the different buffers that they have, all the different types, and you can have all of them bound at the same time. While a non-zero buffer object name is bound, GL operations on the target to which it is bound affect the bound buffer object. So it says non-zero. When a non-zero buffer object is bound, the GL array buffer, for example, target, the vertex array pointer parameter is interpreted as an offset within the buffer object measured. See, it doesn't mean exactly what you think it means. You've got to be very, very careful. That's on non-zero values. Basically, it points to the correct buffer. So it actually says here, instead, buffer set to 0 effectively unbinds any buffer object previously bound. It doesn't say to use GL false. It says bound to 0. And of course you can get GL get will get you whatever it's bound to. I think you're allowed, how many you've got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's 12 buffers there. We've got room for some more. Oh yeah, that's right, because there's all of these silly ones as well, isn't there? There's 32 positions, if I remember rightly. But that would include 0, so 31. And it does specify a glue int. Interesting. So am I right or wrong? In saying GL false? Interesting. don't know. So we've unbound the element array. I'm going to keep GL false. I can understand that. I can't understand 0. I have to stop and look and think. So I've got a GL bind buffer there. I've got one here. So we can copy that down. And I'm going to put GL false in again. So that unbinds that buffer. But these buffers aren't bound. Will our program still work? Nope. No, it won't. Because we've made a mistake. Before we can unbind these, we have to unbind the recorder that we set rolling. What I didn't tell you is that there means start recording. Everything that happens from, if this is a vertex array object, everything from here on in is recorded. That's recorded. That's recorded. These are definitely recorded. Maybe. But we haven't touched the enables. We haven't disabled them. But we still have this here, GL'd vertex array. So I'm going to copy that one down, and instead of putting it at the end, I'm going to break my rules and put it in here. And let's see if we can find out some more about this little baby and what it's actually doing. Because I think this is the culprit that's just blanked our screen. Binds a vertex array object. So it is a VAO. Thank you. Well, why don't you call it vertex array object? You used to. Or 0 to break the existing vertex array object binding. I like the way you say break. Right, that breaks it. It records everything. Do we now work? Oh, we do. But if you don't break it there, do we work? If we do it by my rules of doing reverse, does it still work? No, it doesn't. Why? Because bind is an action that it records, no matter what kind of bind you put in. All it does, it looks for that to record. It sees us binding the buffers, but it also sees us unbinding the buffers. So to protect ourselves, we have to put that back to there. We have to unbind it before it records those, so I have to break my rules. OpenGL was the only time I've ever done that, where I've had to break my rules. But I had to. Otherwise it's going to give us a blank screen. But hold on a minute, we haven't bound it, so how come you're still drawing it? because I bind it before I draw. So if you bind it before you draw, it binds everything that it's recorded. The binding and everything. I'm not doing draw arrays anymore. So everything that was recorded when you created and did all the bindings and all of the... wait a minute, what about the enables? I don't know if it actually does those. Shall we find out? So, what do we got? This one. So it's going to be GL disable vertex attrib array. I bet it is. So if we're doing them in reverse order, doesn't really matter after that, does it? So I've got GL, let's try disable. Yeah, that's looking good. Disable a vertex attrib array. Does that look good? Put a semicolon into it. That was 0 that we enabled for that. We enabled it after binding the buffer. Did we? Doesn't really matter. For this experiment anyway. You can you'll unbind it anywhere within the slot. And you should do. And 1, please. So I've disabled the vertex attrib arrays. What happens? It still works. So it must have recorded us enabling. And of course, I've been lazy here as well. Why am I being lazy about it, do you know? That's your begin, that's your end. That's your rendering. That's how you render whatever's on that vertex array. So now you can start thinking about how could you process this differently with that information. Now knowing that I can do this safely, all of this OpenGL stuff safely, and be able to record it and then very happily put it in here, which we can. As you can see. So that is the basics of OpenGL. Any questions? I wouldn't think there are. It's an interesting topic because you can do a lot with triangles. You can load models full of triangles, lots of triangles, and then you can put those models on the screen in 3D and revolve a camera around them. But cameras are a difficult subject, but not really. OpenGL. So now you've got your first renderer. No, that's not really begin, is it? Let's be honest. That's begin there. You clear the colour, you bind your shader. What did I not do? Because I was lazy. Is it M base? Oh, never mind. M underscore basic shader. Unbind. And that's end render. Those are all the things that you must have within a renderer. You must have a GL clear to begin with. So that's begin pre-render. So that does belong here. Sorry, my bad. And that's begin render. So the renderer must bind a shader. It must bind a model or something to draw, and then it must give the correct indication of what to draw in a draw command. In this case, draw elements, because we have an indices. And then you can undraw, then you can unbind everything. So you have a stage of binding and unbinding. So you bind, you draw, you unbind. And then you can put it into a loop. You'll often see people not doing this bit because they are just as happy to bind over the top, because all it does is it's a piece of data held next to a switch that is turned on. All that does is put a piece of data next to a switch turned off. Do you get it? It's a state machine. So that's a switch turned off. That's a switch turned on with a piece of data next to it. That's a switch turned off with a piece of data next to it. Or a piece of data next to it saying that it is turned off. And it's the data that we read, not the switch. So that should give you an idea of why people don't do the unbinds, is basically because there's really not that much use for it. People have got lazy over time. And it's expensive to do in processing time, because you have to go to the switch and not only add the data, you've got to switch the switch off, which then makes this more expensive, because then you don't just have to put the data beside a switch switched on, you have to switch the switch on as well. So it's more expensive by, my God, a factor of 100. plus, at least, to bind and unbind rather than bind and leave alone. People found this was optional and it was expensive, and to make their graphics go faster, they stopped doing it. That's not what it says to do in OpenGL. If your graphics are going slow, maybe it's the way that you're rendering rather than the bindings. People will say, oh, but hold on a minute. If we run this program through the refactoring tool or whatever it is, what tools have we got here? That these will come up red. Snippets Manager? Wow, what tools? Performance Profiler. Solution configurator is set to debug. Switch to a release configuration for more accurate results. No, you do not. Because then you will inline all my stuff. Change target. I don't want to change target. I want to run my program. CPU, GPU, memory. Do I need memory? Yeah, right. Cannot be launched because another one is currently active. Who activated it? How do I stop it? Probably by doing that. Where's my report? Hello? Ah, well, I'll work out how to use that some other time. Visual Studio is not my preferred IDE. In fact, I don't really like Visual Studio. So we've actually made a shader today. Woohoo! Pretty bad one, but we've made one. Whee! Right. That's me done. We've done OpenGL. We've done it to death. What are we going to do about it? Well, I've got context to do, and also, do I really want to do OpenGL ever again? What would happen if I said no? I've got a mini game engine here that I can write anything in. This isn't in the game engine. This has been written in a user, on the user side, in the sandbox. This is how the user of my mini game engine would have to use OpenGL currently. Is that what you want? Oh, and it is complaining about that one, is it? There you go, and it's complaining. Typical. So, is this how you want to write OpenGL in the future? Is there an easier way of doing it? Yeah. I can write an API for it, and we could probably put it in English. We already have put the shader to bed. Look, see, that's how you make a shader. That's how you bind your shader, and that's how you unbind shader. So I've already got a shader. So that bit I've done for you. I don't have to write that ever again. I can go back and make it a better shader generator. I can do that for you. But what I can't do right now is, well, I don't want. If I'd written that class into here, I've already written this much goddamn garbage in here. Do I really need that class in here as well? No. So I'm keeping that. I'm keeping the shader class. Definitely. 100%. So we've got something out of today. What also we've got out of today is, well, a pile of garbage in our renderer. Rendering. So that's our primitive renderer that we've now made. It renders a primitive. So that's why it's a primitive renderer. It renders a triangle, which is a primitive. And on that note, I'm going to go and feed the cat. And for you lot, good luck, take care, have fun.